thank you all for joining us today for the ECA Southern California spring, I'll call it late spring 2023 workshop. And we have a number of presentations and updates for you today to make it useful for you to do outreach to your communities, the resources you can use, information you can incorporate. And we really appreciate all the work that you do as partners in the Earthquake Country Alliance to help everyone get prepared to survive and recover. And just one more time, as this is a regular meeting, please keep your sound muted. And if you have questions as we go through, put them into the chat. And just as a general welcome, of course, ECA is a large group of public, private, and grassroots leaders. We have committees and regional alliances that coordinate activities statewide, get funding from the California Office of Emergency Services as part of FEMA support to the state each year. And we're administered at USC Southern California Earthquake Center, where I'm based. My name is Mark Benthian. I'm the SCEC Director for Communication, Education, and Outreach. And I also serve as Executive Director for ECA. Our ECA SoCal Coordinating Committee is chaired by our three chairs who are with us today, who are going to introduce themselves.
Okay. So, hi everybody, great to see you all here today. My name is Margaret Fency. I'm manager of the Office of Earthquake Programs at Caltech. I'm also the Southern California Regional Coordinator for Earthquake Early Warning Shake Alert. And I am your one of your Southern California Earthquake Country Alliance co-chairs for this meeting. So good to see you all. Okay, and Heidi?
My name is Heidi Rozovsky. And I'm a inclusive planning specialist with Global Vision Consortium. Here at ECA, I'm one of the chairs. Alan?
Hi, my name is Alan Hansen. I was with Simpson Strong-Tie, the company that manufactures hardware and connectors for construction, but also for retrofitting buildings for 24 years, retired 5 years ago, and came back in to be a co-chair for the ECA. Thank you.
Well, today our agenda is pretty packed full with a lot of great topics that we're going to be talking about, including the events in Turkey and some information about that. Margaret's going to talk about the early warning system, which has been somewhat active in the state lately. We'll also be talking about the 2023 ECA activities and leadership opportunities. So we'd love any of you who are interested in becoming, getting involved in activities and getting into our leadership opportunities. We'd love to hear from you. Mark's going to give us an update on the 20th anniversary of ECA. Where'd the time go? And then we'll be sharing with each other about what we're doing and announcements and discussions. That'll be your opportunity to be able to let us know what's going on with you. And then by 12 o'clock, we're expected to adjourn. And that's going to be a pretty well-packed day today. So let's get on going.
Okay, well, it's my pleasure to introduce Dr. Bora Gençtürk. He's an associate professor in the Civil and Environmental Engineering Department at University of Southern California. His research focuses on the durability and extreme event resilience of reinforced concrete structures with an emphasis on application of high-performance materials. Dr. Gençtürk was a member of the Earthquake Engineering Research Institute's Learning from Earthquakes team that traveled to Turkey to assess impacts to buildings, infrastructure, and communities. Dr. Gençtürk, come on in.
Thank you so much, Alan, for the introduction. Can everybody hear me well?
Yes.
Okay, very good. So I'm very happy to be here. I would like to thank ECA and especially Mark for coordinating this meeting and this presentation. So let me share my slides here. Can everybody see it now? Yes, very good. Okay, so yeah, again, I'm an associate professor at USC, and I'm also the director of our Structures and Materials Research Laboratory, which is an accredited testing laboratory within USC. I'll be talking about the what we have seen in Turkey after the February 6, 2023 earthquakes. So I would like to start with acknowledging a few people and organizations. I have traveled with the Learning from Earthquakes Buildings team. I would like to acknowledge my team members, some of the Turkish colleagues who helped us a lot in Turkey during our visit. The Turkish AFAD, which is the FEMA equivalent of Turkey, some contributors to the slides that I'm going to present today, especially Professor Jonathan Stewart from UCLA and Professor Mustafa Erdik from Boğaziçi University in Turkey. We also had two other teams in Turkey. One is the hospitals team, ERI's hospital teams, and ERI Gears Lifelines team. So they also have contributed to these slides, and we interacted a lot during our trip in Turkey. So I would like to also acknowledge them. So before I go into my presentation, I would like to point out some, I think, very useful resources for you all. One of them is our report, ERI report, which got published 3 months on May 6th after the earthquake. You can easily find this report. It's freely available. It's published through ERI and GEAR. If you just do a Google search, GEAR, ERI, Turkey earthquake report, you will come across this one. And I would like to also point out the YouTube videos that ERI and GEAR have organized. There is several of them on geotechnical, one on buildings, which I was a part of, and other topics. So I would encourage you to look at these YouTube videos as well if you'd like to learn more about this earthquake and the consequences. So this is my outline for the presentation today. As you can see here, there is a lot to be talked about regarding this earthquake. Obviously, I won't be able to cover all of these in today's presentation. So these items here that are highlighted in darker color that I'm going to talk about them more or less somewhat briefly, but I will still try to cover these things. There are many other things that I won't have time to cover them, but I have pointed out some references for you on geotechnical observations. For example, there's our GEAR ERI report. There's ERI buildings team report and webinar on buildings. The same thing for hospitals. There's a hospitals report in the same hospital section in the same report. And then the same thing for lifelines. And, when it comes to Syria, obviously, it's a very different question. We couldn't go there, and there's very little information available compared to what we know what happened in Turkey. So that's another thing I won't be able to cover today. So on the right here, I'm showing you a video that we took in Hatay just to show you the level of destruction. This is one of the hardest hit areas. You can see here, this is as we were traveling with the van. We just recorded this on our phones. You can see the level and the extent of destruction. So there were two large earthquakes, one with magnitude 7.8 and another 7.5. You may see slightly different numbers like 7.7 or 7.9. They're going to be plus minus within 0.1. And then there was a second earthquake 9 hours later, with a magnitude of 7.5. So these are the largest earthquakes in Turkey since 1939, magnitude 7.8 Erzincan earthquake. The fault rupture was over 400 kilometers, which is actually comparable to the 1906 San Francisco earthquake. There was, with this earthquake, we obtained a unique set of records. There is a very dense network of seismic stations in Turkey, and we were able to collect a lot of very valuable ground motions for future use. This region is very economically developed. More than 14 million people got affected from this earthquake. About 3 million people have been displaced, and more than 55,000 deaths, including Syria, and more than 110,000 injuries happened due to this earthquake. About 230,000 buildings collapsed or heavily damaged. As you can see here, the magnitude of the event is very large. I mean, this is not the number of people, but the number of buildings that got collapsed or heavily damaged. And the economic loss from this earthquake is estimated to be anywhere from 34 billion to over 100 billion dollars, depending on which estimate and which source you're looking at. Now, moving on to the seismotectonic setting for the region, the Anatolian plate, most of Turkey, you see these boundaries for Turkey here is the Anatolian plate, and it is being pushed west and southwest by the Arabian plate on the southeast, the African plate on the south, and the Eurasian plate on the north. So it is moving westwards, and you can see the slip rates here in parentheses measured for these different plates. This seismotectonic setting creates two major fault lines, one of them being the North Anatolian fault zone, which is NAFZ shown here on the top, and the second one is the East Anatolian fault zone. And the earthquakes happened right here, right in this region on the East Anatolian fault zone. Just to give you, some anchor points and show you the regional geography. Again, this is Turkey. I will show a lot of zoomed in maps, so I would like to orient you a little bit. So this is Turkey again. This is Syria here, and then on the west we have Bulgaria and so on. The earthquakes happened in this region. So this is the Mediterranean Sea here. This is Cyprus. I would like to use this, the entrant portion of the Mediterranean Sea, where Antioch is right here, as an anchor point, as I show you more zoomed in maps later on. So again, this is your anchor point in the Mediterranean Sea. This slide is showing us the historical seismicity. If you look at these different fault segments here, you see the green areas where an earthquake happened previously that we know of. Like you can see here, there was an earthquake in 1872, these blue numbers, and you can see all these green zones that have ruptured within the last 100 years or 150 years or so. But there was this gap here that was, we were aware of, that hasn't ruptured for more than 500 years. So there was an earthquake expected in this region, and it's exactly where it happened. So this is a map of Turkey's current faults and seismicity. So this is the PGA distribution for 24-75 years return period. As you can see, this region is very highly seismic, and the earthquakes happened exactly in this region. So this slide shows us again about historical seismicity within the last century. I'm going to show you all the earthquakes that had more than 1,000 deaths. As you will see here, Turkey is a very highly seismic region. Many earthquakes happened, and several of them have resulted in more than 1,000 deaths. I'm going to quickly go through these earthquakes. You can see here one major event that I mentioned previously was the Erzincan earthquake, which had about 33,000 people died. It was in 1939. And then you see many more earthquakes aligned with these, the North Anatolian and the East Anatolian fault zones. So there was all these earthquakes happening. There was the famous, very well-known 1999 Gölcük earthquake. I was actually in Istanbul at this time, and I experienced this earthquake. About 18,000 people died, and another maybe 15,000 people were missing from this earthquake. And then the most recent earthquakes that happened this year in February was the Kahramanmaraş earthquakes. As you can see here, this is the deadliest earthquake over the last 100 years or so that happened in Turkey. Now, this is an animation that nicely shows the fault rupture from these two earthquakes. Again, the Antioch is somewhere here. That re-entrant portion of the Mediterranean Sea is about here. This is Iskenderun, and then one earthquake happened on this fault, and then the second earthquake happened on this fault. So I'm going to just play this video somehow. So you can see here that it's ruptured on a site fault, like an adjacent fault, and it went on to the main fault, and it ruptured in both directions. And 9 hours later, there was a second earthquake, which was 7.5, 7.6 that happened on this. This was the first one was what we call the Pazarcık earthquake, and the second one we call it the Elbistan earthquakes. Very large, two very large earthquakes, 9 hours apart from each other. Again, one more time, it's happening. The slip starts on this side fault, and then it propagates into the main fault. And then 9 hours later, there is another fault rupture on this other fault. Okay, so these are all the aftershocks since happened between, after the major events until May 6th. You can see here thousands and thousands of earthquakes happened. This is the first main event, 7.9, 7.8. This one is the second main event. These are considered two separate earthquakes. And then there was a third separate earthquake in Hatay about 14 days later, I think about 2 weeks later, at a magnitude of 6.4. This is the distribution of all the aftershocks. You can see here, this is the number of earthquakes, and then these are different weeks, week 1, week 2, week 3, and so on. You can see here many, thousands and thousands of aftershocks, and then several of them had a magnitude larger than 6. This is a cumulative distribution of all the aftershocks until June 5th, which is very recent. You can see here, since then, there have been about 35,000 aftershocks and several with magnitudes larger than 5 and 6. This is showing the intensity map from the first earthquake. You can see a very large portion of Turkey and Syria were impacted from this earthquake. It was felt as far as Lebanon. And you can see here, this is the second earthquake intensity map. This is an aftershock that happened after the first event. And then this is the very last event after 14 days after the earthquake in Hatay. So you can see the region and the intensity map from this earthquake sequence. And these are the provinces in Turkey that were affected. You can see a very large region. This is which doesn't include Syria. There were 11 large provinces that got impacted from this earthquake. This is showing the intensity map, again, from the Turkish resources, AFAD in this case. You can see the fault line clearly in this multiple segments, but it's considered one earthquake. You can see that the intensity was between 9 and 10 in most places, in some places going even into 11s. This is the second earthquake. That first one was the Pazarcık earthquake. This is the second separate event. Again, you can see it's 9 and 10 in the intensity scale, Mercalli intensity scale. This is very, very large intensities. This is the third earthquake that happened in Hatay. This was a smaller event, but because of the special soil conditions and the basin effects here, which I will mention a little bit more later, we have seen very large intensities even after the third earthquake, the smaller earthquake. Some analogies with the US, Californian, Southern Californian fault structure here. You can see the main fault here, the East Anatolian fault here, and then this is the side fault, which is known as the Sürgü-Çardak fault that caused the second event, which is 7.5 shown here. The 7.8 on the side fault that I shown you here is the epicenter is located here. So the average offset was about 3 to 4 meters, and the maximum slip was about 6 to 8 meters. But in some places, they have observed up to 11 meters of offset, which shows the magnitude, very large magnitude of this event. So there's an analogy here. The Sürgü-Çardak fault resembles the Garlock fault in South California. You can see here, just to orient you again, this is Santa Barbara here, Santa Clarita, and so on. We have the Garlock fault here. There's similarities here in terms of the misalignment of the fault line with the compression axis here. And then if you think about it, hopefully something similar doesn't happen here. But if this Garlock fault becomes like kind of the Sürgü-Çardak fault here, while the San Andreas fault becomes the main fault here, you can see the same type of, fault structure. And these are all crustal strike slip fault, which are, what we have in California as well. So the 7.8 again nucleated on a secondary strand, which is this portion here, and then jumps onto the main strand here, main fault here, which is similar to the 2002 7.9 Denali earthquake. And then 7.8 transferred the stress to Surgu Chardak. The rupture on this fault transferred the stress into the Surgu Chardak fault. And then there was another earthquake 9 hours later. So this is showing the displacement from GPS. You can see here one side is moving in one direction and the other side is moving in the other direction. And if you add them up, -4 and 4, you're looking at about an 8 meters of fault displacement from this first earthquake, a little bit less from the second earthquake, which is shown in this region. So just showing some images of the fault offset here, taken at different locations. I have had the opportunity to see some of these locations like this one. We have been to this one and some others. You can see the fault offset was about, on the surface was about 3 to 4 meters. In terms of ground motions, there, as I said before, there was a very dense network. You can see here just the Turkish National Strong Motion Network within Turkey has more than 800 stations, and there are other network stations. From the first earthquake, this shows the number of records that are usable records, and the total is about, we have 311 two-component recordings with distances from 0 to up to almost 600 kilometers distance. This is very valuable information. And the same thing with the second earthquake. You can see here we had more than 350 records that are usable from the second event. And from the third event, we had about 233 records. All of this information is publicly available now. These maps are showing us the usable and non-usable records. Each of these triangles is a seismic station within Turkey. And then the blue ones are non-usable. Either they're too far to record anything, or they malfunction. Some of the blues you can see here, they malfunctioned, or the data is not reliable. And the green ones are usable ones, and you can see here we had hundreds of very valuable ground motion recordings. This was the first earthquake, this was the second, this is the second earthquake, and this is the third earthquake in Hatay region. These are showing the recorded PGAs from the first earthquake. You can see here, the scale goes up to 2.2 Gs, which is kind of unbelievable. Anything above 1 G is kind of very rare anyways, but you can see here many of these stations recorded PGAs up to 1 G and some of them over 1 G. This is from the second earthquake. You can see the PGA distribution, and then this is the third earthquake. Again, you can see the PGA distribution. And these are the PGA and PGV maps, contour maps from the first earthquake and the second earthquake. You can see very high amplifications here. You can see that the PGAs exceed 1 G. Peak ground acceleration exceeded 1 G in the Hatay region and in the epicentral region. Then I'm going to talk about why exactly this happened. These are the PGV values. Again, it depends obviously, but soil conditions and everything. But the PGV values, anything higher than 50 to 60 centimeters per second is considered very large, and we see PGVs here going up to 200s. This is the second earthquake. Again, very strong motions. You can see the PGA distribution and the PGV distribution here. Some ground motions, showing you individual ground motions here. This is one of the stations, number 2708. It's located right here. The screen marker here is showing us the location of this. You can see the records here, almost over a minute here. And then if you look at the spectrum, response spectrum, this is the period here, and this is spectral acceleration, and the two response spectra for the 475 years earthquake, which is kind of like a design basis earthquake. And then the 2475 years is your maximum credible earthquake, MCE and DBE levels. You can see in some cases, these, in the higher period range, 0.6, 0.7 seconds to all the way to 2 seconds. These earthquakes have exceeded even the MCE earthquakes based on the Turkish building design code. This is another one. This is the Hatay region. Again, there were very high amplifications here. You can see at short periods, there was very high amplifications because of the basin effects that I'm going to talk about later. This is another record. We see the same thing, very high amplifications exceeding the MCE earthquake design level. Between 0.6 to 2 seconds or so. I This affected mostly buildings about 10 stories, maybe 8 to 15 stories because of the amplifications in this period range. This is another earthquake record. We're seeing similar things with these other 2 earthquake records. So now the question is, why was there so much damage in Hatay? So if you look at this one here, you see this is showing all the collapsed building in red in the Hatay region. And the reason is the basin effect. So if you look at this one, this is the known as the Amik Basin, and then the 2 mountain ranges here and the Amik Basin with this river going through this Amik Basin is an alluvial deposit which had resulted in amplifications. There's data on this. If you look at the transfer functions compared to the bedrock, you see amplification. This is 1, 2, 3 here. Amplification anywhere between 2 and 3 in terms of compared to the bedrock motion. So the motions were basically amplified, and because of the basin effects, up to 3 times, sometimes more in shorter periods in this region. And this was known, and these stations were implemented, and this was a known issue. Yet, you know, unfortunately, there was still building major cities in this region. These are some pictures looking at the Antakya Basin. You can see the level of destruction here. This is looking south, the Amik Basin. Again, for geotechnical effects, I refer you to other resources. More images of the Antakya aerial images. You can see all these collapsed buildings, pancake type collapses, unfortunately. And then more aerial views of Antakya. You can see the level of destruction, all the pictures from Antakya. This is another picture from ABC News, which is showing the before image and the after image. You can see all these buildings are basically collapsed around the stadium. This is another city that was severely impacted, the Kahramanmaraş. You can see a before image here and after image. You can use this building as a reference that was still standing. I think this may have been a hospital or a school building. Another image of Maraş, again, you can use this building as an anchorage, and then you see all these buildings are gone, you know, in the background. This is again Kahramanmaraş, a before image, and an after image. You can see several of the buildings collapsed. Again, Kahramanmaraş, you can use this building. The building in the front is gone. You can see this building is gone, and this building here is this building. So in terms of the number of buildings, there were over 2.3 million buildings. I'm sorry, just residential buildings, and 2.6 million buildings in the region. Most buildings were obviously residential buildings, but there were some other commercial, public, and other buildings in the region as well. If you look at the when these buildings were built, again, 2000 is kind of like a milestone for the Turkish building code when it was updated and brought to like international standards. So anything before 2000s, which is about 45% of the building stock, is vulnerable to earthquakes in Turkey and in this region in general. So this is showing us, you know, how the earthquake codes developed in Turkey, starting with the 1904 earthquake code. Again, the year 2000 is which is after the 1999 major Bolu Düzce earthquake with over, you know, 18,000 people, 18,000 deaths. Was the milestone to change the code, and then we consider this part to be the low code and then this part to be the high code. If you look at all the buildings built since then, we are looking at about 60% of the building stock was built after 2000s, while 40% or so of the buildings, like almost half and half, is vulnerable, and the other half is constructed based on the high code or the most recent code. Okay, so I think I already mentioned these. I can skip these. Again, the 2019, the most recent code has similar features to our ASC 7 and the Euro codes. Now, if you look at the building damage, out of the about 1.8 million buildings, or there's a missing zero here, which should be 1.8 million buildings inspected in the region. There was about 50% no damage, 27% moderate minor damage, very little moderate damage. I think this is a misclassification issue, which I'm not going to go into details in the interest of time. And there was some major damage and collapse. If we focus on the ones that are only damaged, minor to collapse, and if we exclude the ones that didn't get any damage, about 250,000 buildings had a major damage or they collapsed. If you look at this distribution now, out of the 780,000 damaged buildings, You can see the distribution between minor, medium or moderate damage and major or collapse. Now, most of the collapsed buildings were in 4 main cities, which are Adıyaman, Kahramanmaraş, Malatya, and Hatay, where Hatay, with the basin effects, constituted over 40% of all the heavy damage and collapse cases, which is in this region. Now, was this earthquake damage predictable? I have found this information. Professor Erdik shared this information with me. This is basically empirical fragility curves. This shows the percentage of buildings damaged in different damage zones based on the intensity of earthquakes. I mentioned to you previously that this earthquake was mainly in the 9 and 10 intensity, right? Mercalli intensity. So if you look at this empirical fragility curve, which is basically based on observations only, right? There is no studies here involved other than just collecting field data from the 1999 Gölcük earthquake. If you look at these percentages, I took the intensity 9, and I took intensity 10. I found the percentages in different damage states. This is moderate, this is heavy, and this is collapse on the very bottom, and average these because let's say it's between 9 and 10, right? Intensity. And I looked at the numbers. So less than moderate is about 34%, moderate is 29%, heavy is 16%, and collapse is 21%. So if I combine this, basically everything moderate and less than moderate is about 63%. And if I combine the heavy and collapse, this is 37%, right? So if I look at the numbers here, which was basically what we observed in this earthquake, and the building stock is very similar, right? So it's whether it's in Istanbul area or it's in the southeast region of Turkey, the building stock is very similar. So we see here this is actual data, this is 68%, and what we said was 63%. So if we were to predict this, we would be very, very close. And the heavy to collapse is 37%, and if you look at the observed data, it's 32%. So it is very, very close. It is surprisingly close. So why was there was this much damage? Most of the building stock is reinforced concrete frames with unreinforced masonry infills. So about 40% of these buildings, as I mentioned before, were built before 2000. I'm sorry, built after 2000, and these adhere to the high seismic codes. And these buildings fared well in general, and then the damage was limited to mainly those two high rises that I mentioned to you between 8 and 15, 16 stories because of the amplifications in that period range. Almost 98% of the heavily damaged and collapsed buildings were built before 2000, which is prior to the high seismic design codes. And these were mainly non-ductile concrete frames, some of which also exist in Southern California, as we all know. And then these buildings didn't fare well during the earthquake. There was extensive inelastic deformations causing these kinds of pancake type of collapses, which resulted in most of the deaths. And then, if you want to do again an analogy, this is similar to almost like a gravity system failing, right? So it's like if you look at the Miami condo collapse, it's a gravity system failing here, a load carrying system failing here, and we see this kind of pancake type collapse, and it is very similar. It's from the earthquake, but regardless, the collapse type is similar, and then the survival rate from these kinds of collapses is very, very low. Okay, so what we did in Turkey is that we looked at a wide range of buildings, types, and occupancies. We focused on newer construction. We focused on locations that experienced very high levels of shaking. We tried to correlate structural damage with ground motion intensity, and to the extent possible, we want to do observations on the consequences of structural and non-structural damage. This is not what we focused on. For example, these kinds of older buildings, you can see there's a missing story here, obviously a soft story type of failure here. This is a kind of a very poorly designed building. You can see a shear wall here without any reinforcement or barely any reinforcement. So we didn't look at these kinds of buildings, very old buildings, which, very obvious why they failed. We didn't focus on those cases. So these are the main areas that we have visited. We stayed about 6 days in Turkey, and then these are showing us the intensity contours for regions exceeding 0.2 G. In our first day, we were staying in Adana, and then we went to Iskender and Antakya region. The second day, again, we were mainly in Antakya, and then we went all the way down to Samanda. And the third day, we looked at Osmaniye, Kahramanmaraş, and we moved on to Gaziantep, and then we started staying in Antep. And then fourth day was our longest day. We went to Gölbaşı, then Adıyaman, then to Malatya, and then seeing these regions. And fifth day, we went to Maraş again. We didn't spend enough time the first time we were there. And then the last day, we went to Nurda, Slahiye, and Hassa region. So this is the whole coverage. We covered a very large area. We split into 2 teams every day. And then all the dots are showing all the sites we have visited at these locations. So these are all the major towns we have seen while being in Turkey. And then we created this database of buildings, which we visit over 130 sites and more than 190 buildings, individual buildings we have seen. Looking at what we have seen, it was mostly residential. And if you look at the lateral load resisting frame, it's mostly reinforced concrete frames with shear walls. And the maximum PGA explained that these locations were very high, as you can see, ranging from 0.2 to 0.7 G, and the PGV the same, ranging from 20 to almost over 110 centimeters per second. In terms of number of floors, most of the buildings we have seen were in the range from 6 to 15 stories, some lower and some higher. We didn't see anything more than 20 stories high. Didn't exist in the region. And if you look at our classification of damage for the about 200 buildings we have seen, they were mostly in heavy damage classification, about 50%. Obviously, this is not very objective because we were mainly picking up buildings that are, that showed more signs of damage. But we also picked some randomly selected buildings to, make it more or fair or uniform observations. These are the types of damage we have seen. You wouldn't want to see like a diagonal cracking, which is an indication of shear failure. Rebar buckling, again, is a failure mode that you wanted to prevent. Concrete crushing is kind of expected for such extreme events. And plastic hinging, unfortunately, with the plastic hinging, although the percentages are high, these plastic hinges didn't develop properly because of detailing issues. Again, unfortunately, I won't have the time to show you all these damage observations from our visit. I wanted to make this presentation more of a high-level presentation because I knew that the audience would be more broad. So I could use another presentation or even more than one presentation to talk about these things in the future. There was a hospitals teams that I mentioned before. I encourage you to look at their webinar online. And then one interesting fact here is that the region had an average of 17 beds per 10,000 people, which is very similar to what we have in California. We have about 18.7 beds per 10,000 people these are acute care beds. And then the observations from hospitals was very valuable. They created a database like we did for buildings. They created a database for hospitals, and they did an excellent job, looking at their functional, whether they're operable after the earthquake and their functional recovery following the days after the earthquake, days and weeks. These statistics don't belong to, I just want to make it clear, these are coming from one of my colleagues in Turkey. This is not from the ERI hospitals teams. The educational buildings did very well in general. Only about 3% collapse out of 20,000, which is still not acceptable, but much better than the residential buildings. 4 hospitals were non-functional or partly functional due to the earthquake. 15% of the healthcare facilities were non-functional due to non-structural damage. Hospitals did in general very well, except for a few in Hatay and Iskenderun. But there were issues with the functionality because of the non-structural damage. So these are showing some of the damages to structural components and non-structural components in hospitals. Again, there was a Lifelines team as well in Turkey. This was a GEAR ERI team. I encourage you to look at their video online, and they talked about many things: transportation, water, wastewater, energy facilities, industrial facilities, bridges, and all that. This is a summary of what we know from in terms of the lifelines. Again, this is not coming from the ERI lifelines team. This is coming from my colleague, Professor Erdik at Boğaziçi University. And if you look at the damage to highways and railways, they were mostly due to fault rupture, surface rupture, rock falls, or soil problems. Some cases, these impeded the response and recovery efforts. Out of over 1,000 bridges, only 15 had some damage. Most critical transport routes were open within 2 days. And good thing is that these bridges were designed and built following our codes here, ESHLA and Caltrans codes, very similar codes, and they were built under the supervision of government departments. So there weren't much of inspection or construction quality issue with these bridges. The dams also did very well, except for 2 dams, one in Turkey, and these were earth dams, embankment dams, and they had some cracks. Other than that, the dams did very well. Hydrocarbon pipelines, roads, and railways were damaged, but they're not extensively, and they were able to resume operations within 1 week after the earthquake. There were some issues in the port of Iskenderun. There was a major fire 1 day after the earthquake, and then this port unfortunately couldn't be used for emergency supplies or as an entry port to the region, but it was opened within a few days partially. These pictures are showing the road damage, bridge damage, some examples. There was damage to the runway at the Hatay airport. There was some lining failures, falling of the lining in one of the tunnels, and then railroad damage. Now, what is next? So rebuilding. So they're estimating that about 230,000 buildings need to be demolished ASAP, or they already collapsed. Government, the Turkish government promised to build about 490,000 homes within a year, which is obviously very ambitious. We will see how that goes, but about 405,000 new urban housing and 83,000 rural homes. They already started construction on many of these. They're working on building new homes for the people affected from the earthquakes. But several more will still need retrofitting and reinforcement. In terms of retrofitting, I'm going to skip this slide quickly in the interest of time. There's a law that was passed back in 2005 after the Gölcük earthquake in 1999 that basically requires all the deficient building stock to be retrofitted or replaced. They're estimating this to be costing around $400 billion. Just in Istanbul is going to cost $100 billion to replace those buildings. This has started in 2005, but the renovation rates have been very low. And one of the major reasons for that is that people do not want to leave their homes and go stay in rental places until their homes are retrofitted or replaced. So what is needed here, and this is pointed out by Professor Erdik and heavily advocated by many people in Turkey, that a special retrofitting campaign, which I think also can help our non-ductile concrete buildings here in California as well. If we could retrofit them externally without having to move people out of these buildings, I think these efforts will go much faster. So these kinds of external frames, if we can design some systems that can be modular and implemented and installed relatively quickly without causing a major disturbance or having to move out the residents, then I think these efforts will be much more effective to improve earthquake resistance. So we will be doing some more detailed studies. This is very interesting. This is one side of the street, and in Turkey that we have taken pictures of. This is the other side. So this side is completely gone, and this side just looks as if nothing has happened. So why did this happen? So we need to do more detailed studies looking at soil conditions, special building types, and all that. Now, going into the conclusions quickly, I think I used more time than I should have. There are many aging buildings in Turkey and that were presumably designed based on the older codes, and these didn't do well. The severe shaking, obviously, 2 major events and several aftershocks with a magnitude of 6+, added with the basin effects, have resulted in in severe losses. And the Turkish seismic hazard maps do not consider basin effects. I think USGS have implemented these basin effects in certain locations at the most recent updates, which is a great thing. But in Turkey, the probabilistic seismic hazard maps, they don't account for the basin effects. The buildings that were built after 2000, with according to the more modern codes, they did well in general, but there were again problems, as we have seen in the field. Maybe they didn't collapse, but they were not usable after the earthquake. They had heavy damage that they will still need to be, I think, demolished and rebuilt. There was a combination of design, construction, inspection problems. Again, I couldn't go into the details of individual things we have seen, but that could use another presentation in the future. So the type of infill walls construction prevented the columns to respond as designed. They use in Turkey these very heavy infill walls that are made of either brick or CMU blocks. So that have affected the building response. And then there were some, unfortunately, official amnesties to buildings. Obviously, the intent was to help people to get municipal services. They were given occupancy permits to buildings that were not regulated, that were not built according to the codes, or they were not inspected during construction. Now, we all know this. On the paper, it looks very easy, and I think we know what to do. But when it comes to implementation, it is kind of very difficult to implement these things. So the basic tenets, I would like to remind all of us, the basic tenets of earthquake risk mitigation. We would like to quantify and understand the existing risk. I think in California, we are doing an excellent job. We know what is deficient. We know exactly what needs to be done. This is not the case in other places like Turkey. They do not exactly understand the existing risk. We still have some issues, I think, in California, especially when it comes to the residents being in seismically deficient buildings. Some, as far as I understand, some are not completely aware of the risks. The second item here is do not increase the existing risk, right? Build properly. Again, this is not an issue for us in California. We are very strict with the building codes and inspections and all that. So I do not think we are increasing the existing risk. Now, we need to decrease the existing risk, right? This is the biggest challenge, right? We need to retrofit, we need to do urban renewal, and this is our biggest challenge in California. How do we decrease the existing risk? And then transferring the risk, right? We need to do insurance and so on. So we need to also work on that a little bit more. Improve disaster management, emergency management. We are working very hard on this. I think we have very good emergency management plans in place. But in other places like Turkey, some improvements are needed. I would like to thank you all for your patience, and I want to conclude with this nice image here where our team, Los Angeles County Search and Rescue Team, was saving a child. This picture was taken in Turkey. We are grateful for all their efforts and showing this selfless rescue efforts in Turkey. Thank you, everyone. Thank you for your time.
Dr. Genschert, thank you very much for your very thorough presentation. And if you could keep your slides on in case we want to go back and show anything for questions. The learning from earthquakes teams that go to these earthquakes all around the world, gather so much important information about, of course, the earthquake they're studying, but it's really meant to have application and really be learning for what might happen here. And you've outlined a number of issues that really are expected here. The basin effect situation that we know will amplify shaking into the many of our most populated areas. They were nice flat areas for agriculture and then for homes and buildings, and I'm sure that's similar in Turkey. And so that seeing that what we can learn from other places can help improve what we have here. Also, of course, the concrete buildings, of which we have so many that you outlined. We have a question from Alan about another type of construction. It can be also in the non-ductile concrete, but just a general soft story construction where there. He's asking, was that widespread too in terms of the damage?
So just to understand the question correctly, is soft story damage is widespread or not? Is that the question? In
Yeah.
Turkey? So yeah, I mean, soft story collapses were very widespread. These are some images that from those kind of soft story collapses. This one and that one. Again, we haven't specifically looked at these because I mean this is very well known and very well understood. We wanted to focus when we were in Turkey more on more newer buildings that didn't have these kinds of obvious deficiencies, but still had some failures. We wanted to understand and learn from these. But yes, I mean this was the major cause of collapses in Turkey in the recent earthquakes.
That's what your slide here is that the team wasn't focused on trying to learn what was obvious from these types of buildings that were well understood, but more on what was unusual given buildings that should have performed better given their new construction.
Correct. So I mean, I have about 80+ slides here, and I have another 150 slides or so showing all the different types of issues that are in the modern building codes. I mean, in modern buildings in Turkey. That I couldn't have a chance to talk about.
And for our attendees, there are policies that cities are beginning to implement to require these non-ductile concrete buildings to be retrofitted, and the soft story, especially the apartment buildings that have the small 1 or 2 car slots that you can drive into held up by poles. So these are beginning, but only in the last few years, and only a few cities so far. So this type of information can help make the case for the real need for that. There's also a question, Laura, of the collapsed building. Is there any information on how many collapsed in the initial 7.8 versus later quakes? Was that able to be gathered given how quickly they were? So only a few hours in between.
I'm not sure if I haven't seen in in the reports and all that I have seen. I haven't seen that kind of delineation between whether they collapsed in the first earthquake or the second earthquake. One thing I know from talking to the people in Turkey is that there was the first earthquake and then there was the second earthquake. So after the first earthquake happened, many people left their homes because obviously they were scared and they didn't know what was going on. Like I'm trying to find a map that shows this well. So the first earthquake happened here, and then in these cities, Malatya, Diyarbakır, and Adıyaman, and so on, people left their homes. And then these regions were farther away from the first earthquake, and they, there was serious damage, but not many collapses. And then people left their homes, and then the second earthquake happened 9 hours later, and then that was actually earthquake was closer to these areas, several of the collapses happened during the second earthquake in this northeast region. And then luckily people were outside at least most people were outside during that time, and then collapses happened. And we heard from the residents that many were telling us that, luckily we were outside our homes, and then that's when our building collapsed and so on. So I know that in the northeast region, like especially in Malatya, Adıyaman, and Diyarbakır, most buildings collapsed during the second earthquake, and the people were not at their homes. So that reduced that toll.
That's great news. Yeah.
That was the silver lining.
Heidi has asked for the newer building codes. Do you happen to know how they are incorporating aspects of accessibility, for people with disabilities, and in those codes? Or is it even a factor that's included, or do you know?
I'm not sure, but I don't know if there's a correlation between the seismic code and accessibility requirements. I think accessibility requirements would be more on the architectural, parts of it, not the building design codes. So I don't think the two will be related.
Of course, buildings less likely to fall down helps everyone. So, including those who may not be able to walk out, maybe using wheelchairs and such. Okay, so looks like just one other factor. Early on, you talked about all the valuable recordings of the earth, the shaking near the near the fault and around. And how is that information used, not just to learn what happened there, but for our design and codes and aspects construction here?
Yeah, so those records are very valuable because this is one of the largest crustal events that maybe the best recorded event or crustal event that we know of. So these earthquake motions are very representative of crustal, strike, slip, fall. These were shallow earthquakes, right? Which are very similar to what's happening here at the San Andreas fault, right? So if you want to do any analysis of buildings, these in California, these records will be extremely valuable because they reflect the seismotectonic setting within California. So that's why I think these recordings are very valuable for our, understanding of crustal strike slip earthquakes.
We haven't had earthquakes of this size, well, especially the 7.8 range, since we've had recordings.
Yes,
California.
these kinds of high technology instruments, like there was a 1906 earthquake. Obviously, we don't have much records or any records from that, and since then, there was a gap in large magnitude events. These records will be valuable.
All right. There's one more question. You mentioned the kind of the similarity with the Garlock faults and the San Andreas. Are you familiar? Is that the San Jacinto, Sierra Madre, Cucamonga similarly concerned as a secondary earthquake, kind of an earthquake pair? Is that also similar?
Yeah, I mean, I wouldn't be able to comment on that. I would rather, refer that to our, seismologist friends and engineering seismologist friends. I'm not an expert on that, so I wouldn't want to comment on that.
Okay. The point, though, we do have these similar relationships and faults that can trigger earthquakes on even further away faults, which is a good transition to our next.
And we have seen that before in many locations, not just in California or in Turkey, but we have seen multiple fault ruptures within the same event, and it is very common in these large magnitude events.
Well, thank you again. We will move on. I just want to let everybody know that we are recording the meeting, and if I did put a link in the notes to so basically the recording and the presentation slides will be available on the same page where you registered, and I'll put that on here again, and then you can also get note if you're not a member of ECA already and want to get updates and news of upcoming events, do join us at earthquakecountry.org/join. And right now, Alan, I believe you're going to turn over to our next presenter.
We're going to have an update on the earthquake early warning system, and Margaret Vinci is the resident expert on that. So Margaret, take it away.
Okay, thank you, Alan. And I want to thank Bora for his wonderful presentation. This was very enlightening as to the similarities between Turkey and here, but also to people that are asking about our buildings here. So thank you so much for that presentation. So last month or last quarter, I reported that we were pretty quiet here in Southern California. We were kind of on average, we do have between 30 and 50 earthquakes a day. But in the last quarter, we've actually kind of exceeded that. Some of those were the Ridgecrest aftershocks, but we've had a lot of activity up and down the coast of California. Here in Southern California, these are some of our major events. So we've had over 5,000 earthquakes this quarter. That's from February to today. 156 of those were actually quarry blasts, so they weren't actually seismic. And out of that, 435 were magnitude 2s, 52 were magnitude 3s or above, and we had 6 magnitude 4s and above, and we had no magnitude 5s here in Southern California. However, up in Northern California, they did exceed that, and they did have some magnitude 5 events up in that area. So some of the notable events that we have had here was a magnitude 4.2 at Mount Palomar. This also triggered the shake alert earthquake early warning system. In the end of April, we had a magnitude 4.1 near Heber, again triggering the system. On April the 30th, we had a swarm down in Nylon. Now that isn't unusual, and a swarm again is actually, we have those in several places in California, but mostly around the Salton Sea, over by Tom's Place in Nevada, and then up by Mammoth Lakes. So a swarm is where we'll have a lot of small earthquakes, kind of close in time together within a few days. Usually they're very small events. There is no main event. Why do we have them? We're not quite sure. We've only been studying earthquakes for about 100 years. So one day we might know what actually this means, but right now we're not sure. But it doesn't usually develop into anything, they die out. The biggest earthquake in that was on April the 30th, was a magnitude 4.3. And that actually did trigger the alert system here in California. And then our biggest event was a magnitude 4.3 at Big Pine on May the 20th, and which also triggered the shake alert system. Next slide. And so this actually is some of our triggered events, not just here in Southern California, but all across the Western states. So in February, we had no events that actually triggered the system. In March, we had one event. In April, we had 4 events, and in May, we had 5 events that actually triggered the system. And of course, the system is triggered for a magnitude 4.5 earthquake and an intensity 3 of shaking where you are. So even though we may have reached that threshold of a magnitude, doesn't mean that you're going to get the alert triggered at your location if you're underneath that threshold of an intensity 3. And so all of these actually, except for Heber, if you were in that location, you would have gotten that triggered event. But most of Southern California didn't see an event this quarter with that. I think the last one we got was at Malibu, and that was in January with that triggered event in Malibu. Although I do think there were some people that felt the Port Hueneme event on May 30th. That was also a triggered event. It was offshore, but I think some people near the coast did actually get a triggered event. Next slide. And so just a reminder about our shake alert earthquake early warning system. It is working very well. Of course, we test this on a daily basis. We are constantly looking at the system. We are constantly improving algorithms. One of the issues that we had some time ago was earthquakes that happened near the boundary of another state. So let's say where our sensors in California will pick up an earthquake in Nevada. So when those waves travel across the border, our sensors pick it up. And of course, it takes time for it to hit all of our sensors to determine that that was a Nevada event. This has been almost diminished. So we don't get any fault alerts with those kinds of occasions very often anymore because of the new algorithms that have been put in place for that. So of course, earthquake early warning is for public alerting. So to be able to get it on your cell phones right now, that's the only means we have for public alerting, because we don't have those air raid sirens anymore that we can send those over, but we do have some companies that are working on that. But right now, of course, you can get it on WEA. So on your Android phones, on your iPhones, if you have WEA turned on or your notifications, you will get a WEA alert. However, that's for a magnitude 5 intensity 4. So it's a little bit higher threshold with those. And then the authorized apps. This again is different than notification. So earthquake early warning is only available on 3 authorized apps, and that is MyShake, built by UC Berkeley, Quake Alert USA, which is a private company, EWL, and SD Emergency, which is San Diego. And this is actually earthquake early warning that is put onto their already existing app that brings you all of their emergency information as well. And MyShake is for Washington, Oregon, and California. Quake Alert USA is Oregon and California, and SD Emergency is all of California, but not just San Diego. I will also note that San Diego, the SD Emergency app, will also bring it to you in Spanish. So it does have the ability to do Spanish on that means as well. Also, for anybody that has an Android, of course, Google is automatically sending it to all their Android phones. Again, you just need to have your notification turned on. And we do not want to forget our automated actions. This is where the savings is going to be when we have a large earthquake. Of course, public alerting will be to get people into a safe place, but damage, being able to mitigate some of the damage before it happens when the shaking starts, is going to be done through automated actions. And so this is being able to slow down trains such as Metrolink, BART, and LA Metro are doing, being able to open fire station doors, trucks aren't stuck inside, being able to have surgeons not operate. So many uses, being able to turn off water valves so that you don't have flooding, many uses for automated operations and actions are being done today, and not just through public alerting. And then again, through PA systems, so you have that more a viable and the more useful way of getting the alert, where cell phones may not always be operational in a large earthquake. So you will get the main shock because the damage hasn't happened yet, because the shaky may not have reached your location yet. So cell phones will be operational for the main shock, but there again, cell phones are at the mercy of that earthquake. Cell towers may be down. They only have 2 hours of electrical backup. And so cell phones may not get the aftershocks. So wanting to make sure that people have the alert over the PA system and a more sustainable means of getting that alert. Next slide. So I want to point you to our website at shakealert.org. This is where you can find out all information about Shake Alert, where the cell phones are. You can actually download it right from our website. I will tell you, we are in the process of overhauling this website. Right now, it has a little bit difficulty finding things. So we are in the process of overhauling this website. So maybe at one of our other meetings, we can actually do a walkthrough of the new website, showing you where all the information is, how you can utilize it, how you can use it. And this is also materials and information that you can use to talk to your organizations, be able to talk to your people that you work with within your organizations, to be able to bring awareness of Shake Alert to the community so that everybody is using earthquake early warning, and to be able to use those materials. Next slide. And so here are some of the materials. We have a messaging toolkit. In that messaging toolkit are short animations. There are movies that actually show you what earthquake early warning is. We have tests and drills and exercises that you can utilize. This was actually done with Earthquake Country Alliance. And these being able to use for shakeout drills, being able to use the Shake Alert message for your shakeout drills. We also have done some case studies. So we have about 7 case studies that we have done with water companies, with our transportation companies, of how they have implemented earthquake early warning into their systems. What were some of the challenges? How did they get buy-in? What was the cost to them? And we have done these for healthcare facilities, some of our hospitals. And so we have these case studies to show how other people have implemented earthquake early warning. And so this would help you to get buy-in within your organization, to show you the cost benefits to having earthquake early warning implemented. We also have guidebooks. We also are doing DEI. So we have inclusive and culturally competent messaging. There again, the way that you can utilize this in talking to different organizations in different languages. We also have many of our materials printed in different languages. So we have Spanish, we have Chinese, we have Vietnamese, we have Tagalong, and we have Russian. So then many of the things that we have, you can utilize them in the different languages. We also have one-page handouts. So a fact sheet that tells you what is earthquake early warning, how does it work, how you can utilize it, and then it goes showing you to where to get down and load the cell phone apps. Next slide. And so also wanted to talk to you a little bit about an article that came out this week. It was talking about, it was a study about the Salton Sea and shrinking, how shrinking may reduce earthquakes. Of course, the San Andreas Fault starts at the Salton Sea, goes 800 miles up through Palm Springs, up and back of the Cajon Pass, and then up Highway 5 into San Francisco, out into the ocean, where it's recycling itself back into the core of the earth. So it's about 800 miles long, but at the southern portion is at the Salton Sea. And this southern portion actually, the San Andreas Fault runs into the goes from the Salton Sea into. So when we talk about the San Andreas Fault, it is 800 miles long, but the southern portion is the Salton Sea to Parkfield, California. So when we're talking about the southern portion, and with this study, this is what they studied. And so this is the portion that they're actually studying. It's from Parkfield, California down into the Salton Sea. The Salton Sea was actually formed in 1905 when the Colorado River flooded. And then it has been fed over the years by agricultural runoff. It actually was called the sea, but it's actually a lake. Even though it's called the sea, it actually is a lake. And so over the years, it has been fed by this agricultural runoff. But in recent years, of course, we've had many droughts, which has then dried that up. And so the lake actually is shrinking. So it's getting smaller. So this is what this study is all about. Is with shrinking of the Salton Sea, then are we reducing the risk of those earthquakes? Because the weight of that water then causes stress on the San Andreas Fault, which is likely to trigger earthquakes. And actually the last month, we've had over 1,000 measurable earthquakes at that portion, on the southern portion of the San Andreas Fault. But that weight, of course, is diminishing. And so what the study is about is to whether that's going to change the risk along the southern portion of the San Andreas Fault. So at times when the lake was full, we had 30 times more water than we currently have today. The weight would then push down the Earth's crust. It lubricates the faults, boosting the chances of having those big earthquakes. And so now that it's drying up, is that risk still there? Next slide. And so the system actually has been locked for 300 years. The southern portion, now by the Salton Sea, has not seen an earthquake since 1725. There have been 6 or 7 events over the last thousands of years. So the average of a large earthquake starting at the Salton Sea has been about every 150 years. But the longer the region goes, the more stress that builds up and the more larger that earthquake is likely to be. Water is only one factor that influenced the seismicity of the San Andreas Fault. And so don't forget the 1857 Fort Tejon earthquake that traveled 250 miles from Fort Tejon into the Los Angeles basin, creating that 7.9 earthquake. So this water factor is only one factor. So the risk along the San Andreas Fault in the southern portion has not been diminished. The risk is still there. It's all about plate tectonics. So water is one factor, friction is one factor, but it's all about the plate tectonics. So we sit on the Pacific plate. The Pacific plate is moving into a year to the north, and it builds up all of that stress. So our risk is still there. So even this is a great research to be able to show what is happening to them. There's also people that actually want to put more water into the Salton Sea, bringing it from the Baja Bay and bringing it into there, but there's no intention to bring it to the level that it was hundreds of years ago. So they don't intend to bring it that high, just to bring more water there, because of course this is a great hydrothermal electric area where they're pulling that steam out of that water. And so they're using it for that. So they actually want to raise that, but they would not raise it to the levels that were hundreds of years ago when we saw these larger earthquakes occurring. Next slide. And so I now want to turn it over to Cal OES to talk about what they're doing with their outreach and education program. We all work together with Earthquake Early Warning in California. And so wondered if John was online. And
Yeah, I don't see him here.
Okay, then I'm going to go ahead and do his report for him. So again, we all work together as one big family to bringing earthquake early warning to the residents of California. So recently, they've been doing a lot of outreach and education. They are now partnering with the Major League of Soccer partnership to promote earthquake awareness. They're going to be bringing the shaker truck to their facility. They're going to be doing handouts. They're going to be talking to them on a regular basis, to the residents that are people that are visiting going to the major soccer league. They're also going to be staging a discussion for a shakeout tour. They did this last year in October for shakeout. They're going to be doing it again, to be taking their earthquake simulator to all the various towns around California. And as soon as they get that button down, they will let us know where those are going to be, so that we can help them to publicize this. And again, this is bringing awareness to all the residents of California to be utilizing earthquake early warning, because it's no good to have it if people are not utilizing it, and also to know what to do. So it's all about the education and knowing that if you feel shaking and you get an earthquake early warning alert, what are you going to do? You're going to drop, cover, hold on. You're going to then use protective actions. So if you cannot drop, cover, and hold on, you're going to sit down in a chair. You're going to bend over, protect your inner organs. If you are in a car, you're going to pull over to the side of the road, set your parking brake, lay down on the front seat so that you have a barrier if something falls on your car. If you're in bed, you're going to stay in bed. And unlike earthquakes that we've had up in Eureka recently, and they have had magnitude 5s, they've had the early warning going off, but unfortunately people jumped out of bed and did drop cover and hold on. So they need, again, this is why we have shakeout, to practice what you're going to do when the earth shakes. Be able to know what you're going to do. If you're in bed, you're going to stay in bed, and you're going to pull the covers up over your head. You're going to turn your inner stomach to the mattress, and you're going to put a pillow over your head and wait for the shaking to stop. And then you're going to put on your protective shoes and your light so that you're not tripping over things. So with that, with the simulator that Caltech or that California is taking around the state, they're going to be sharing that message as well to make sure that people know what to do when the earth shakes. They have currently confirmed sites at the National CERT Conference that will be held in San Francisco later this month, Del Norte County Fair in August, San Diego and San Francisco Fleet Weeks, and they just finished Fleet Week in Los Angeles, which was earlier this month. And so they're very active bringing that around, and I actually worked with them in Malibu on Saturday, and we had a lot of people, and it was a great event there. So thank you very much for our quake update date.
I'd just like to say, if you're interested in hosting the Shake Simulator, especially in the week or so before Shakeout, or a week or two for that tour, we're helping to coordinate that. So I'm going to put my email into the chat and reach out to me, and I can help get that perhaps for your event. We're looking at, in general, during that time period for events that leading up to Shakeout. So if you're doing your Shakeout exercise early or having a public activity leading up to it, we'd love to know about that too. And so go ahead, in both cases, email me. I'll put that in the chat here. Do we have any questions for Margaret on her presentation?
And I just
Put that
put
in the
in, I just put in the chat, I put in a location for the one pager for the cell phones. So if you want to distribute that to any of your people that you work with and the community, you can. It's the one pager on where to download for your cell phone.
Excellent. And while if anybody has other questions, put in the chat. I made a little poll, Margaret, that I thought would be kind of fun to test with our attendees. So we'll see how this goes. I'm going to launch this. The window should pop up on your screen, and it's just, you can answer as many of these questions as is right for you. So what option do you have for receiving the earthquake early warning alert? Do you have wireless emergency alert set up, like an Amber Alert, to where you'll get those? Do you have an Android phone that maybe you will receive that you may have MyShake or the other apps. And of course, also the option of not having any option yet, in which case now's the time. So I'm seeing the results come in, so we'll just let that run a bit. And what I'm seeing is a lot of people having MyShake. And of course, wireless emergency alert. Everybody, you might get that and an alert from your app too. So you can get it through multiple ways. But Margaret, you really don't need to have multiple apps because they're going to have the same service, right?
You don't have to have multiple apps. I actually am running all three because I'm actually testing them. But you don't have to have them, and each one does something a little bit different.
Yeah.
So you might want to look at them, look at the inside, see what they're offering, see what they do, and each one does something a little bit different and offers something different for everybody. So look at all three, see which one fits your needs to be able to.
Now, Margaret, I see a question here, and I think you'll have info. My app is Shake Alert LA. Is that one of the
okay.
apps?
All right. So Shake Alert LA was actually a test market. So the city of Los Angeles had money that they could put in and build an app to be able to show other people it could be done. But they didn't have the money to actually maintain it. It was never meant to be maintained. They just wanted to show that it was feasible so that other people would actually build the app. And so it was actually put out of service a year ago. Unfortunately, I think a lot of people that were running the app did not get that message that it had been discontinued. So go ahead and discontinue that app and download one of the others. I will also say it's probably a good practice too, that if you've been running one of the apps for maybe 6, 7, 8 months, it doesn't do any harm to reload it about every 6, 7 months. I know some of these app developers are making changes to their apps. And so it's a good practice to maybe actually reload those every once in a while. But go
There's
ahead
a
and
comment here that I think is a common maybe misunderstanding, that someone suggests that they have something called My Earthquake Alerts Pro. And
yeah,
so there are all these apps that have been around for a long time that tell you where the earthquake was a few minutes ago, after the earthquake happens. The US Geological Survey has a way that you can, and a lot of, for many years, about a way of getting the information about what happened. That is different from the earthquake waves are on their way, and you're getting a signal that's before
mhm.
that other alerts. So those other alerts you might have, earthquake apps, they're good for knowing where things happened around the world, but they're not early warning.
No, it's a post-earthquake tool that may come minutes after the earthquake has happened. The
Yeah.
only authorized earthquake apps is MyShake, Quake Alert USA, or SD Emergency. And Jackie, I can help you find those. So I will go ahead and email those to you.
So you should be seeing the results of the poll now. We didn't have everybody participate, but you can see that many people have probably both the wireless emergency alert, MyShake, maybe even the Android built-in, and also other apps. And only a few people answered that they didn't have the option yet, but we know that there were others who didn't respond. Okay, well, thank you very much, Margaret.
Yeah, I just want to mention one thing too. Some people that have not downloaded it, some people don't want to have GPS tracking, but MyShake has, you can put a home base where it's not using GPS. You could just put in an address and we'll only send alerts to that address. I mean, so it's not actually tracking you by GPS to show you where you are.
The
And give you an
drawback of
alert
that is that
wherever you are.
if your home base is in LA and you happen to be in San Diego, you won't get the alert.
You won't get the alert.
Yeah.
That's right. If you
You
turn off the
only-
tracking, then yeah, you don't get the alert.
For where you are, yeah.
Mhm.
Okay, and then there's a final slide that you had for some links.
Oh, sorry about that.
No worries.
Yeah, so these are just some of the resources. Thank you.
Okay. Alan.
Oh,
Chief.
yes, I'm supposed to turn it over to you, Alan.
Here we
Got
are.
I'm turning it over to
Got it.
Alan, who's going to talk about SoCal activities and leadership opportunities.
Thank you, Margaret. So, well, we have a number of things coming up. The second round of mini awards. So this is unique for this year, but this is something that we wanted to give a chance for various groups and organizations to apply for. ECA SoCal Summer Workshop, August 9th. Now, this is an in-person event. So this will be talking about the ECA's 20th anniversary and the Northridge 30th anniversary kickoff. So that's going to be a great one. That's going to be at USC. October 19th, obviously, 10:19 at 10:19 in the morning, Great California Shakeout. Please register for that. We want to find out how many people are planning on participating in that sort of thing. So, and then November 8th, ECA SoCal Fall Workshop. And as they say, more information to follow. So just keep track of the earthquakecountry.org calendar, and you can see exactly what we have coming up. So the coordinating committee, well, obviously Heidi, Margaret, and I are the co-chairs. We have a number of other coordinators. We do have an open position as an assistant for Marilyn Jimenez. We have open positions in each county for Pay Lee. I don't know, Pay would love to get some more help there. John Hammett and Lance Webster, volunteers for the Events Bureau. They are finally getting back out there and doing some in-person events after the whole COVID thing. Shakeout Events Coordinator, Pauline Lewis. John Snoddy with the city, or Jeffrey Snoddy, I should say, with the city of Inglewood, the communications coordinator. We have 2 other open positions, so if you possibly don't have time yourself, please let some people in your organization know about that. Those are definitely some valuable positions we have open: quarterly workshops coordinator and membership coordinator. And then obviously the SCEC regional liaison, Gabby Noriega with SCEC. There's her contact information. So thank you very much for paying attention. Hopefully we can get a few more people in these various positions. Take care.
I'm putting that email into the chat too, for if you're interested, you can follow up at SoCal@earthquakecountry.org. Thank you, Alan.
And I'm going to mention that this is a great way to network with a lot of the other people that are on these committees, not just our committee regionally, but our state committees as well. So this is a great way to network and get to know people and utilize all the materials that are available for your organizations.
Margaret, I just saw a question going back to earthquake early warning. Quick, I'll just ask it. With MyShake, if tracking is turned on so that you'll get an alert where you are when the earthquake shaking is about to arrive at your location, right?
Right.
But you've also loaded a home base that's somewhere, and you've traveled to somewhere else. Will you get the alert?
Yes.
Where you
Yes.
travel to?
Yes. You can turn. Yes. Yes. You can have both. And so if you can do, yeah. Oh, you know what? Let me think about that. You know what? Let me get back to you with that.
A good question.
Yeah, that is a good question.
You're
And
just
you know
unclear.
what? I was thinking that yes, it was an added feature that you get it both out there and you get it in the tracking if the tracking is still turned on. But you know what? Let me double check that, Mary. And if you can put in your contact information, I will get back to you on that.
It's Lynn Glenn, and
Who is it?
you could direct message Margaret Vinci if you like through the participant list, if you prefer not to share your information with everyone. Also, a comment I'd love to share, and I think it's fantastic that Tony Safford notes that Habitat for Humanity California is applying for a FEMA and LOES grant to do retrofitting of older homes in low-income areas, for low-income homeowners in high seismic areas throughout the state, similar to what the California Earthquake Authority has with their earthquake brace and bolt. If you have not had, if you or someone you know has a house with a raised foundation and you either haven't had it retrofitted or aren't sure if it's been retrofitted, that definitely is something you should consider. And there are increasing opportunities on the horizon for having that work done with either like a $3,000 incentive, or perhaps having that work done without any cost. So thanks for sharing that, Tony. And also, Mary's asking, is there a charge for hosting the earthquake simulator? And so what LOES has done has been to lease one of the simulators from the company Safety Proof.
And he'll be back. Yeah, he'll be back in just a minute.
Yeah, let me just, that's never happened where I've, in all the meetings we've been doing, I haven't been kicked out. So had to happen one time. I was saying that the simulators through LOES that are bringing to events wouldn't have a charge. There are additional simulators through Safety Proof and Ready America that are available that may have a charge with them as well that you can get for your event too. So typically it's something like for the full day, it can be between $2,000 and $3,000. They're very expensive to maintain because they're basically shaking themselves apart by design. Not apart, but you know, they're the maintenance cost is quite high, so that that's the fee. Okay. Well, I'm going to go ahead and move on. to talking about yet this part, I guess. Oh, Heidi, were you going to introduce me?
If you like. One of the things that we are very, very happy to see is what started as a little organization of a few partners has grown and has really thrived. And so our 20th anniversary event will be coming up, and I will turn it over to Mark to give you the details.
Yes, so back in June, actually on June 16th, 2003, at USC, we had a meeting that was the first meeting of Earthquake Country Alliance as a kind of a new concept, partly to plan activities for the 10th anniversary of the Northridge earthquake coming up about 7 months after this first meeting, which we then were able to coordinate. What was starting to happen is a lot of people were starting to plan different events. So there's going to be a lot of things happening at the same time. We said, how can we come together and coordinate what eventually became a big event on the campus of Caltech, and with several thousand people coming to that. But we also updated our guidance and resources and talk a little bit about what has come from there. And again, we've grown. We were SoCal, Earthquake Country Alliance was first just in Southern California, but eventually with our creation of the Great Southern California Shakeout Drill in 2008, we had contacts and colleagues from the Bay Area that came down to SoCal for that and said, we want to partner with you on this. We want to bring this statewide, and also Earthquake Country Alliance statewide. So that's basically, while we've been in existence for 20 years, wasn't until 2009 that we were actually statewide. And so to this day, we have our website at earthquakecountry.org, and also now in Spanish at terremotos.org. And we, in addition to creating and still organizing Shakeout in California, we also are very involved with Tsunami Preparedness Week and lots of webinars and things, as you know. Back in 2003, leading into the anniversary of Northridge, we updated a booklet at the time called Putting Down Roots in Earthquake Country and created the 7 Steps to Earthquake Safety, which has continued to be our primary organizing framework for our messaging. And so hopefully you know about this, and that we really encourage you to tell people about these resources and use them and link to these on your web pages. This is not an ECA thing for us only to use. ECA was created for all of us to have shared resources and shared activities so that we don't all have to make our own thing. So in addition to the information, we now over the last couple of years have translated all that guidance, 7 steps in many forms, and also self-protective action guidance into now 16 languages, which you can find on our website too. And of course, we have our sector-based coordination and outreach committees that we really encourage you to be a part of. Our events bureau, which has speakers and booths that will bring to your events, and you can request either of those at earthquakecountry.org/events. We have a form that you fill out that will then let you tell us all of the information about what you're wanting to have, the speaker topics, etc., or if you're wanting a booth. As Alan mentioned, our ECA Mini Awards program that we've been coordinating for more than 10 years now, at least. I forget what year we started, but this is providing free materials valued up to $500 or even $1,000, non-structural materials or educational materials. We don't give you the money, we give you the materials. And we typically have had one application period each year. We actually are going to have another one about to start. We didn't get a lot of applications, partly because the application period kind of spanned the winter holiday, and so it was probably hard for a lot of people to gear up in the 2 weeks right after the holiday and put in the application. So we want to give people another chance to get the materials and complete them by the end of November. So look for emails about that. Look at earthquakecountry.org/mini awards is where you'll be able to find the updates when those become available, or when the application updated application is available. And I put some links into the chat just about those. I can find the mini award link so that you can copy it. There it is. So all of this is just part of what ECA has been creating. And of course, our biggest activity that, has even gone global is the Great Shakeout, Great California Shakeout, as with other areas, is happening always on the third Thursday of October. This year is October 19th. And you can have your drill on any day, though, and at any time. But a lot of people will have their exercise right there at 10:19 a.m. on October 19th. We have more than 3.5 million people already registered this year. That's going to be climbing very quickly. And we encourage you, if you haven't renewed your participation yet, go to shakeout.org to register or renew your activity. All of this is going to be what we're commemorating on August 9th at USC. You're all invited to come, and we'll have information coming out soon with how to register. We anticipate invited speakers and news media, USC leadership, and others. Really, our home being at the University of Southern California administratively, and we'll have some presentations from our many award recipients from earlier this year to see what they've done. We will also be kicking off the Northridge 30th anniversary campaign. So like our original meeting back in 2003 was for the 10th anniversary, now we're at the 30th. And announcing kind of what the activities are going to be for that. We're planning a number of big events around the region with our Quake Heroes documentary film. I know many of you have seen, maybe even earlier versions, now complete, and we're rolling this out. And so even on this day, perhaps because so many people may have seen already, we may have an optional if you want to stay to see the film if you haven't seen it yet. These will be showing the film, as well as having a 7 Steps to Earthquake Safety preparedness fair. When we've done this, it's been remarkable. The response of the attendees, our partners and vendors who are there signing people up for CERT or other alerts or selling supplies or earthquake fasteners, have said they've never seen something like this before in terms of the eagerness of the attendees to get trained, to sign up for alerts, and to become better prepared. So we're really excited about bringing those events and many others as part of the anniversary. So definitely save the date for August 9th, and we hope to see you there. Okay, and then I haven't been looking at the chat. Let me just see if there are any further questions from before we move on. And okay. Again, and I'm going to put a link right to it. Also, we do have, before you leave, we do have a survey. You've been seeing it on the slides. I'm going to put the link right here in the chat too. Please do complete that. It will be really helpful. Now we're going to turn, I believe, to Heidi. You're going to welcome all you to participate in sharing announcements and what you've learned today, et cetera. I'll turn it over to Heidi.
Well, this is your opportunity for those of you who are on the line with us to tell us about what your organization is doing, or maybe even something that you need some help with. So any announcements, and then maybe even something about, is there anything interesting that you learned today, or anything you'd want more information on, or anything about a topic or idea that you'd like to see our SoCal ECA to bring to you. So I'm going to ask you to put your announcements, at least to start, in the chat. So Mark, can you read those off as they come in? Or would you rather have Mark, I'm going to ask you, would you rather have we open it to the voice, or would you rather have
let's just go ahead and hopefully we don't have everyone speak at once, but if you can go ahead and come off mute if you like to share something. You can put links in the chat as well, but we're looking for things that are of interest to this community earthquake or preparedness, more broadly, events that you're having, things you want to share, resources, etc.
or even
Philip, go ahead.
Hello, everyone. My name is Philip Schultz. I'm the Community Preparedness Coordinator here in the city of Riverside. So I'm excited to share this Saturday. We hosted the Riverside County CERT Field Day. So that was a lot of fun, kind of practicing what we're going to do, and all those different skills that we learned during CERT. We also are planning on hosting our annual Ready Riverside Public Safety Preparedness Expo in September for National Preparedness Month. Mark, I just submitted the the request for someone to come out for that. If y'all are available, we'd love to have you. Yeah, and then I think especially with the presentation, it was a great several presentations. So thank you all for that, and we're excited to just learn more about all the different faults in the area and how they may interact, and how we may have to deal with that. So thank you.
Thank you, Philip. Rafi, would you like to speak about the summer camp that you put the link into the chat? You don't have to say anything about it. We see, go ahead.
Hi, this is Jasmine and Rafi with LA City EMD. So we're hosting a sort of a camp for youth ages 15 to 25. So we're focusing on the Gen Z generation who are interested in either emergency management or anything in regards to, response. It's a Monday through Friday camp here at our EOC. So the days will be July 31st to August 4th. That's like pretty much the first week of August. And so if you all want to share this link with your colleagues or anybody, organization that has youth among that age group, that could be greatly appreciated so that we can have many people, be able to explore this camp that we are offering, and we are able to, offer our resources to other people as well.
Rafi, Jasmine, is that, are there any limitations on who can attend? Either you'd have to be in the city of LA or LA County or?
We are prioritizing city of LA students, or participants, but I mean, if you have space, we're hoping for at least 45 participants. Right now we have like around 20. So I'm sure there will be space. So I wouldn't say no to others who are interested that are applying that are out of the city.
Thank you.
Okay.
Any other announcements?
Hey, Mark, this is Alan Hansen. So in our homeowners association, we've been doing block parties for the various residents and taking the Macri neighborhood shingles that Margaret is so familiar with. And we've been talking about what to do, how to be prepared, showing them contents of a go bag or CERT bag, feeding the group lunch. And then we mark the utilities with yellow tape for gas, red tape for electrical panels, and blue tape for water supplies. So just a way to get people to know that they do need to be able to turn it off. And if they're gone, maybe it'll help somebody else to find that in the event of an emergency. So just a little something we're doing in beautiful Murrieta.
Alan, what were those colors again?
So yellow was for the gas line, gas valve. Red is for the electrical panel for the main breakers, and blue is for the water line. So
I would consider, you might want to consider the fact that there are a lot of people that are red-green colorblind. So you might want to take a look at either another color or something that's more neon that can be identified easier as a shade difference.
okay, I'll look into that.
Thank
Any
you,
other-
Alan. And let's see, we brought it, and then I'm just looking at the chat here. Okay, I'm gonna share something myself here, just and I'm gonna put a link into the chat for this. If you are interested in today's presentation, there's another one coming up, a bit more on the geology and seismology similarities between Turkey and California, and that's this information here. So June 24th, Turkey webinar. And so here's the link for registering for that webinar next week. And the let me just see if it's on. Just looking at a description here. So yeah, that's basically all. You can find out more by clicking on the link for that webinar. Any other, and Eric, I see you have your hand raised. Eric from City of LA, right? Eric, you're muted if you're speaking.
Oh, thank you. Great presentation, Margaret and Alan. I wanted to make a plug for the area amateur radio operating groups like Aries and DCS and ACS. For the Great Shakeout Day, they'll be passing a lot of radio messages, and they will be passing along Did You Feel It forms. So I noted the future meetings that you have, so maybe I'll make a more formal notification to let people know how they can do that, especially radio ham operators that may not been practicing recently to get their skills back up to speed up. Thank you.
Fantastic. So if you're a amateur radio person and would like to learn more about that, you could directly message Eric here through the chat. And we'll also be sharing information, as we did last year, about the opportunity of participating in those Shakeout Day coordination activities through amateur radio. Okay.
Great. Thank you, Mark.
Thank you. We'll kind of move to, you can still share announcements, but, oh, Margaret, go ahead.
Well, I just noticed that Tony Safford put in a message that he's doing a Habitat for Humanity California. And this is a grant by FEMA and Cal OES that's similar to the EBB program. So I'm gonna look into this, and oh yeah, this could be something. Oh, so you already shared it?
We did, yes. I think it's fantastic.
I must have been going off to find out about my shape.
Yeah. It's just great to have more opportunities for everybody to get that work done. There's only so much funding that for the current programs, and so that's hopefully. Oh yeah, as Tony mentions, yes, got to get the grant first.
Well, but this could be something we could have for maybe a meeting down the road as to more information on how to do that.
Heidi, oh, I'm sorry, Danny, you've raised your hand. Everyone's piping in now. Go ahead, Danny. Danny, you have your hand raised? We're not hearing you.
Is he unmuted?
Doesn't show as muted, but we're not hearing. So maybe you can put your announcement or in the chat, Danny. Sorry about that. Okay, Heidi, we have our little bit of final discussion here. If you want to kind of lead this part too.
So based on the things that we heard and were presented to us today, do you want to share something about, this is open to everyone, what you learned, what maybe you just decide you're going to do, because of what you heard, what you're going to use, what you will tell others. How are we incorporating this into our organizations and putting the information out to the people that our organizations are involved with? Anybody want to open up and talk about any of those?
And you could certainly type it in the chat if it's just something short, or you can raise your hand or just speak out. Eric.
Thank you again. What I learned, what jumped right out was I had assumed that gold rush at Salton Sea for lithium, if that activity would trigger or exacerbate the possibility of seismic activity. So what I learned is that that's not necessarily the case. It's more the weight of the water sitting on top of those tectonic plates would be more of a factor than that kind of mining activity. So that was great.
Thank you, Eric.
Is there
You bet.
anything that, I'm sorry, Mark, go ahead. Oh, I thought you were saying something. Is there anybody who's, based on some of the information that we've shared or something, that would really like one of our partner organizations to maybe work with them or help with, or can we coordinate getting in touch with people if there's something that's really maybe something that's in your bailiwick? You know, we'd like to be able to force multiply with what we're doing with all of our organizations and partners that are working with us. So is there something that you feel you need to be help with connecting into? Do we have a resource that can help you? How can we help each other? I see everybody's got rumbling tummies ready for
question.
lunch.
I'll just say, everybody right now put something you learned today into the chat. And I'll go ahead and I said, okay. The other way of asking that, is there something you're going to do today newly from what you've heard or learned? Is you maybe some of you are downloading an app like MyShake app. Don't be shy.
Nobody's going to be drawn and quartered. We just want to make sure that we as an organization are helping to support what you all are doing. So if we can help connect that, and if we can, you know, if you know that you learned something, but you've got questions about how do you implement that in your organization or something, think about the steps you may need to take, who you may want to talk to, and how we can help each other.
And we're getting a lot of great responses here about the warnings, the information, the similarities between Turkey and California, the Habitat for Humanity plan and grant plan, that there were 3 separate earthquakes in Turkey. And that really is something that can happen here, you know, even if it's not right next to each other. A 7.8 on the San Andreas, which would affect the whole region, could trigger an earthquake, let's say on the Palos Verdes fault or the Newport Inglewood fault, you know, not even connecting directly to it. So we've seen this before. It can happen. We can have an earthquake, as we did with the Ridgecrest sequence back in 2019, where on July 4th there was a 6.4 or 5 earthquake, and the next day, that next evening on July 5th, there was a 7.1. So we could have a larger earthquake follow, and that didn't happen in a very populated area. If that happened right underneath the metropolitan Los Angeles area, the damage would have been much greater. Thank you for all that you're sharing in the chat, and hopefully everybody's seeing that about the comments that what you've learned today. And is there anything in particular that you might tell others from today's workshop? You can add that into.
One other
comments?
one other question that you may want to add into the, add something in the comments is there a topic or something you would like to hear more about so that we can look at that for planning future workshops and meetings on meeting the needs that you have to help you work together to provide this information to all of our constituents.
You could put that in the chat, and that's also one of the questions in the survey. So when you complete the survey, that definitely let us know what you might be interested in. All right. Thank you for your presentation or your participation today. Thank you to our presenters for your presentations and our chairs for leading our today's workshop. Again, the recording and a PDF of the presentation slides will be on the website where you registered. I'll try to find that link again here by the end of this week, so you can share that with others, or if anything you want to review, it will be there. Here's the link to that again. And a comment about if the earthquake happens when you're in bed, stay in bed. You can roll over and put a pillow over your head. And that's a partially advice. And having that under bed bag with your shoes and tied up, and so that glass can't get in them, with a flashlight and socks, and really key, very basic, something you could do today so that you won't be walking through broken glass when the earthquake happens, if it happens at night. So
another thing about being in bed is take a look at what's above you, so that you're not putting tchotchkes on shelves or something right above the bed.
Right.
So make sure that you have that you create safe space for yourself where in places like the bedroom and so forth.
Margaret, you have the final word to adjourn and to
Final word is thank you for everybody attending the meeting today. It's always great to see all of you. And remember, August 9th, we will be doing our next meeting. Put it on your calendar. This is going to be a very fun event, and looking forward to seeing all of you and networking with you in person.